Hi everyone, welcome to this Xoogler community meetup. My name is Chris Fong. I was at Google 2006-2015. I founded this community and I fell into running this community to bring a lot of great knowledge to all of you. If you ever want to speak or to host an event, just email me, chris@xoogler.co. We have over 300 events a year, in person, hybrid, and online like this. And I'm so glad the Google Cloud folks actually reached out and said they want to volunteer and educate so many Xooglers around the latest that's happening here. So what I'm going to be doing is actually passing this over to Jagan. Jagan is a group product manager at Google Cloud. We also have two more speakers, Neha, who's a data management engineer, as well as Karthi, who's a senior staff solution architect. I'll come back at the end to help moderate the discussion, but thank you again, Jagan, and your entire team for being so helpful to the Xoogler community. I'll turn it over to you now.
Thank you so much, Chris. Really appreciate it. First of all, a huge shout out and thanks to Christopher for leading the community and also giving us an opportunity to come and present and share with you what we've been doing within Google as in the areas of data, in areas of AI, and to share what we've been working with in our enterprise customers in terms of building intelligence apps and share this with you. We're hoping to have this conversation be super interactive, so keep those questions coming. We have a time set aside for Q&A towards the end where we'll sort of have more long-term questions. In the meantime, if you want to put your questions on chat, that would be super appreciated. Also, a huge thanks to our Xoogler community for joining this call. Really appreciate you being here and giving us an opportunity to share what we're doing within Google Cloud today. I'm joined by my colleagues, Neha Bhatnagar, who is a customer engineer in the data management team. She works with our North American customer base from, in the tech, in financial services across North America. And we have Karthi Thyagarajan, who is a senior staff solutions architect who works in implementing these solutions for our customers, working closely with them in their trials, as well as engagements to implement Google Cloud solutions. So let's get on with it. So we're hoping to have this be super interactive. I promise there'll be a small portion of this will be slides. The rest of it will be all live demos. So we want you to sort of see how the product in action, not just what we're showing in slides. So that's a quick picture of ourselves. You already know all of us now. So one of the things, and this is not a surprise to any one of us that's in this group, which is the fact that Gen AI is really coming across all of our industries, across geographies, across verticals. And we're seeing it really transforming the way business are looking at business processes, looking at the way they perform different customer interactions, and really find a way to transform how they run their business as well in terms of improving efficiency, improving personalization, improving customer retention, and really make the organization super energized towards having a more motivated, data-driven organization in there across the world. And because of this, we will see that there is this imperative. You'll see this not just in the organization that you're part of. You'll see this at the C level. You'll see at the developer level, being able to use these capabilities to build new experiences in terms of software development, as well as make the whole process easier. So really across the board, every company, every industry, every geography is investing in this to make themselves more competitive. And really 2026 has become the year of agents, which is really having agents drive everything from customer interaction beyond just sort of a simple chatbot that can answer questions to a chatbot that really understands your particular customer account, understands the products that you got, understands the knowledge and how you've used the product, and then gives you specific responses when you connect with a telco, when you connect with a gaming company, when you connect with an entertainment company, to provide all that in a super personalized way as well. And for employees, being able to get access to resources, being able to get access to perform transactions in payroll and make that automated as well. So really using a combination of both data as well as LLMs to provide really personalized, tailored interactions happening not just in these, but also in security, being able to detect, to diagnose, respond, and take interventions when there's a security threat. But the challenge for a lot of our customers is the fact that to be able to solve this today, we need to have the data coming together. And today, data traditionally exists in multiple types of data. So for example, you have traditional relational databases, of like Spanner, like, like Cloud SQL, like, Oracle, and all the others. That's typically how organizations have led, organizing their data. And then we have multimodal data, which is data in text, data in graph, as well as new data that's in vector embeddings. And there have been specialized databases for this. And finding a way to connect all of this through graph models is something that, again, organizations have bought specialized graph databases for this. And this has become a challenge for our customers because they find that all these different data sets in different products have created these silos of data, and having to synchronize and coordinate them and keep them, up to sync has created a data pipeline. And so there's a lot of time that has gone invested in addressing these. So we think that there's a better way to solve this instead of having these data in these different subsystems, is to really provide a unified approach across all of these, by which all this data can come together in a single structured, synchronized form, by which you can manage and build new next generation applications on this unified data store. And we think that product is actually Spanner. And a lot of you, as former Googlers have seen Spanner talked about in different Google properties. And we're here to introduce the new Spanner, which is the multimodal Spanner that provides a single platform for not just relational database, but key value, but also full text data, vector embeddings, and graph, as well as provide an analytical platform to do long-term analysis all on the same data. And we've continued to retain all the things that are goodness about Spanner, such as the ability to scale out, strong consistency architecture, all the privacy and compliance we expect, lots of high availabilities in both single region and multi-region deployments, as well as the price performance, being able to sort of have optimized scale out architecture to be able to scale back down when you don't need the compute. It's a really efficient way to run your compute. So as you can see, and as you know from before, Spanner has been used not just to manage Google properties. All the Google photos, all the metadata is all managed in Spanner. All the data that comes from Workspace is saved in Spanner. All YouTube videos, all the tagging, all the metadata about comments, everything is stored in Spanner. So really, it's not just used by customers, but has been originally, its roots are in serving these high capacity in terms of size, as very, very low latency in terms of under 5 milliseconds serving. We've been doing this for a long time for Google, but now we've also extended this as a cloud product, making this available to enterprises such as Home Depot, enterprises such as Wayfair, Walmart, for different subsystems. So we really see this being proven in real-world workloads, not just for Google internal, but in commercial across different verticals as well. So what we're here to talk about today is really some of the innovations that we've built in and we've invested in, essentially to make building agentic AI applications super easy and super helpful based on our unified data platform. It starts with an agent development kit. So agent development kit has been released by Google Cloud that allows you to build agentic apps. And we've built specifically tailored solution for Spanner that allows you to connect these different components together to be able to run sample agentic apps by which your agent can interact, ask questions. So what are the things that your agent needs? First of all, you need their agent to be multi-agent. This is coming from the agent platform that allows you to have a master agent in which you have individual tasks being handled by sub-agents so they can coordinate with the master agent to perform tasks. We had a Xoogler talk about their time in Google Flights. So this is a great example of how when they can come in and show me a flight reservation. So there's an agent that looks up flights, that agent that looks up seats, that agent that looks up airlines, the agent that looks up frequent flyer. All these things are different sub-agents that perform these tasks to come back with a recommendation. So that's really the multi-agent architecture that we're seeing here. And the QR code that you see there will actually take you to a GitHub entry on agent development, a blog post that Karthi has created on how to build agentic apps using Spanner. And so we have connected this not just with Gemini that allows you to connect with the latest Gemini 3.1 model that just released a few days ago, which allows you to use the latest model to ask natural language questions, things that are coming in from the user, and translate it into the specific dialect of the database that we are using. In this case, Spanner, it'll ask those same questions and it'll convert those responses and return them and ground them in the LLM so that the responses is helpful for the agent to respond to the user with specific responses based on the data that's coming in from Spanner or any other database as well. And we have sort of a full, there's a whole separate architecture on how we protect the security of agents using, model armor, which is security technology that makes sure that the infrastructure for identity and authorization is fully integrated into the agent model so that it doesn't perform any untoward actions that you don't intend the agent to do. But beyond the ability to have these tasks be automated through agents, you need the ability to perform multimodal search. Let's take a classic sort of retail application. You're looking for a shoe store. If you look for cool blue shoes, what is the definition of cool? Cool is sort of a very loose, sort of human term that you might, and how do you translate that into relational queries? And the answer is relational actually does not allow you to do that. And this is why we need more semantic understanding. And this is where the ability to have a multimodal data by which instead of looking at a catalog of type shoe, but can also perform a representation of what cool is, in which case you can use the vector embedding space to go and look for different assets that match semantically what cool represents. It could be different colors, it could be different shapes, it could be something that C-level execs are wearing. All those things, or movie stars are wearing, or all those things are category of what's cool. So this is really being able to combine that. And so Spanner provides the ability to store not just perform keyword searches, like you look for a word like blue, but also translate cool into something like a semantic understanding of what that is, and use that to find those shoes. And because we have the ability to maintain history, we can actually take that data across different users who look for similar patterns and have bought shoes based on those patterns. We're able to use that to present to you relevant items using Spanner's high super fast serving, which will deliver these results in seconds. So this is being used by different industries, by different customers today on top of Spanner. But beyond sort of searching for objects, if you think about searches are really require a fair amount of structure to this. If you look at, for example, trying to search a 401k, a 10K of a company, on one hand, it's really one massive document. So one would think it would map directly to vector embeddings. But there's a whole bunch of entities within them. There are officers, there are business units, there are different sort of products that they have. So you can imagine, you can read a 10K of a company and construct a graph model of the different entities that make up that. And then you can track those entities using not just, and you can ask questions like, is this business investing in risky assets? So you can go back and look at the structure of the company, the business units, the products, and be able to come up with combinations, first of all, building that structure, finding the products, and then using essentially vectors embeddings to search what is risky, what is not risky. So this is really by which you can construct these models. And Spanner supports graph, which is the ability to perform and create graph models on top of this data. So it allows you to extract these entities, create these embeddings, create these graph models, and then use that to perform graph searches using the entity definition that we store within graph. A couple of other things we've done to make this process really easy. We've not launched this, so we're actually releasing information about this. We expect to be launching next month, which is AI functions. So today, to have to run these searches, you have to run the searches outside a database, because the database does not allow you to run these searches today. Because these are certainly vector searches that can be performed directly in Vertex AI or any other third-party model. But today, we'll be introducing the ability to perform AI if functions, which allows you to take in directly a user request, like find me cool shoes, and translate that directly to the database. And the database will take that and run a semantic filter on that by converting that statement for a cool shoe into a vector search directly, and be able to run the query using that particular string as the user represents it and convert to vector search and bring the results back. Once you bring the results back, you need to be able to rank it, which means you need to score it to see which is the highest match, and then rank them, and then pick the one that most meets the user's needs. So really, we've made this so that all these capabilities are part of the database, so your applications become super easy to build and operate. Another area, and you'll see a QR code as well for the doc link for the integration of MCP tools and Spanner, which is we have provided, MCP servers exist today that allows agents to talk to different assets. So you have MCP servers that allow you to talk to databases, MCP servers that allow you to talk to maps, and all these different properties. Today, and this is just last week, we announced the ability to have a managed MCP server. So instead of you having to deploy servers running the MCP server itself, Google provides a managed service, just like Spanner, to run this MCP server, and you can connect to any Google asset and have direct your agents to use that, which means you don't have to set up servers, you don't have to manage it, you have to maintain it and update it. It is provided as a managed service on top of all the other Google services, by which you can essentially talk to any data source, including Spanner, ask questions of it, and that will translate your agent request directly into a SQL query through the MCP moderated conversations taking place with Spanner. And that QR code will take you to the doc link, if you like. As I'll come to the end of our presentation, one of the things that we talked about, we heard about a lot of interest in anti-gravity. We've built integrated into anti-gravity connectivity for MCP servers, by which you can directly talk to the database through anti-gravity, which means all you have to do is connect to anti-gravity, use your Google authentication, and that will give you access to the MCP servers. You will choose the Spanner MCP servers and find the Spanner MCP servers, configure your database that you want to talk to, and then use essentially your agent. And Karthi will show a demo of this, how that happens by asking questions of your data. So in the developer environment, as you're building your application, you want to ask questions of your database, like, hey, is the country column a highly, is there lots of high distribution, or is most of my data just coming from a few countries? If you want to ask questions of products, like, hey, which products is, are product equally distributed, or are certain products being bought more than others? So this allows you to build these tailored applications and do this within your IDE, such as anti-gravity, without having to leave it and ask questions and having to come back from a SQL editor into an IDE. So all this is done using natural language, so you don't have to construct any schema to do this. You can directly ask questions of it using natural language and get the responses. So as a first step, I'd like to turn this over to Neha, who will be walking us through a demo of how you use multimodal capabilities within Spanner. And then we'll turn to Karthi to show how you can build those same multimodal capabilities using an application like anti-gravity and Gemini CLI. Neha, take it away.
Thank you so much, Jagan. And that was super insightful. Hope you guys are having fun. I'm sure you guys would agree that building a sophisticated AI application, like a smart AI travel planner, often typically means juggling multiple databases. But as Jagan mentioned and showed the slides, Spanner is multimodal. So we have built a travel agent that kind of showcases Spanner's multimodal capability. And I'll be going over some queries and show you a demo of this particular agent. So our agent needs to help a traveler plan a family trip to San Francisco. Now, what questions or searches you think you're going to be running if you're planning a trip to San Francisco? Few things I can think of, help me find attractions, top beaches, activities, or maybe like family-friendly restaurants. So our agent is fully equipped with running these searches and provide the relevant results to you. Let's dive straight into how we build this AI travel agent on Spanner. Let me share my screen with you. Jagan, would you mind? Yeah, thank you. Just give me a thumbs up, you guys. Can you guys see my screen? Fantastic, thank you. All right, so here in Spanner console, this is a Spanner Studio, and the Spanner multimodal is our project. So you can see our entire database schema is in one place. We have standard relational tables here, like attractions, restaurants. So they're kind of holding your structured data. And then we have a table which contains vector embeddings, semantic chunks. That's going to power the semantic search. We've also defined a knowledge graph. This is our property graph. So here we're shifting from seeing isolated data points to seeing meaningful relationships. And the graph is on the right side, as you can see already. So this is basically connecting the where to the how. And it's ensuring that destination isn't just nearby, but it's truly accessible and relevant through the lens of the user. So what are we observing here, guys? There are no separate databases. There are no complex sync jobs. There is no ETL, which I call it as endless troubleshooting loop. I know what it means, but just kind of making fun of it. But this is what the idea is. So let's see our travel agent UI that can help the traveler plan a trip to San Francisco. All right. So here we have our schema script as well. This is what I was showing you. The DDLs are here as well on the application. We have a little over 10 search queries that might be of interest to our travel planner who's thinking about traveling to San Francisco. There are different examples, as you can see. We've categorized these queries into OLTP, OLAP, vector, full text search, graph, and a final magic query that consolidates all of these models, and it kind of shows that these models are fully interoperable within Spanner. But let's get started. I'm going to show you a very basic top rated attractions query. We can start with a simple query to find the top rated attractions. So you can see this is a traditional OLTP search. The query is retrieving these top rated attractions and activities. They're categorized as good, very good, and it returns a maximum of 10 results. You can also see on the right side, we have query intelligence powered by Gemini 3 Flash that can walk you through the query so you can follow the syntax along. Fantastic. Let's move over to the other example. Maybe we want to look for best beaches. Again, this is a very simple query, guys. A traditional keyword search. I'm using a like keyword operator here. And you can see my query. I'm saying like beach, like coast, like ocean. All right, all the synonyms right there. What's the problem with this particular query? If you misspell a word, or you kind of have to use all synonyms, it may or may not pull all the relevant results correctly. So in my query, you can see I've added all these synonym words here, right? So what can I do to make this better and how I can improve my experience? This kind of goes back to what Jagan was saying. We've got semantic search built in Spanner as well. And that's what I'm going to show you here. So we're going to run exactly the same question, but with the semantic search query. Ooh, fancy. All right, so let's look at the results. You can see here that, the query retrieves much more records than OLTP because it's able to understand that coastal gem in the description column is conceptually related to beach. So even if you don't explicitly use the beach keyword, it's pulling the records like Fort Funston, which is a beach part of the Golden Gate National Recreation Area. Let's go over the query real quick. So this is taking our question as natural language. What are the best beaches? And it's providing the raw text to the LLM model. And as the output, the model returns a vector, which the query then uses in the cosine distance function to rank your chunks of data based on how closely their meaning matches your question. So it automatically links shoreline, coast, beach, without you having to manually define a synonym list. And that's how the semantic search runs in Spanner. Well, this isn't enough, right? I want to run something more ambitious. So how about a request which is like much more complex, more profound? And the traveler, let's say they want to find out the family-friendly dining conveniently located near top-rated beaches. So to show this in action, let's run our crown jewel query to see Spanner's full power, where all these models are completely interoperable. A multi-model query. But let me go over the query first, and then we can see the results back in the application. Again, the question that we're trying to find out here is, show me the attractions that are family fun, are conceptually near the beach, and count the restaurants close to them. So here, we start off with a graph traversal to find the restaurants that are close to those beach attractions. Then we do a full text search that finds literal matches for family fun in descriptions. With joins that define our OLTP query for all those relational lovers like me. Let's move on to semantic search that uses vector embeddings to find attractions that are semantically similar to the phrase beaches. And then finally, we use an OLAP query to find a count of restaurants that are close to those attractions that provide the actionable insights for the user, our traveler. All right, let's go back to our app and see if the results are here. There you go. The spanner is seamlessly combining all these query types to give the traveler exactly what they're asked for within a single call to the database. So as you can see, consolidating your architecture into a single spanner instance really kind of removes the complexity of managing these fragmented data systems, and it's the ideal tool for building modern, high-performance, multi-model AI application. All right, over to you, Karthi.
All right, thank you, Neha. Let me share my screen here. Okay, can you all let me know that you can see my screen, please? Okay, great, thank you. So, by the way, it was great to get some context from Xooglers on this call earlier on, just to see, what you're expecting. This topic that we're presenting is quite broad, and we've, Jagan presented kind of the broadest overview and lots of art of the possible, right? So definitely keep that in mind. And then as we're progressing all the way to my section, my session, we're trying to kind of zoom in on what a practitioner can do, right? With kind of the tooling across the Google ecosystem. And Neha just presented a great survey of what Spanner can do. Now, this can seem like we're just talking about Spanner, but one of the cool things that I realized, and I come from AWS, not to knock AWS. AWS is awesome. Spanner brings the ability to build these really intelligent applications with one service, and that really simplifies things. And it's super. It's amplified when you have these AI tools. So I hope you all can keep that in mind. So with that said, just to give you a quick idea of what I'll be walking through. Once again, we wanted to distill information in such a way that we could present this to you in the 15 minutes that I have. So it's kind of a tips and tricks kind of session. So initially, we'll kind of go over what a practitioner who's having to dig through all of these tools when they're building these distributed applications, what they can actually accomplish with LLM coding assistants like Gemini CLI and anti-gravity. So this can be as simple as listing tables, doing queries in the way Jagan mentioned, using natural language. This allows you to stay in the zone, right? Like you're not having to pull up a browser, you're not having to remember the exact G-Cloud syntax. All of that becomes a lot more friction-free. And then we'll talk a little bit about tool use. Jagan pointed out that we released a fully managed MCP server, not just with Spanner, but a number of Google services, including pretty much all of the database offerings that Google Cloud has. And we'll look at what tool use looks like from a couple of different lenses. And then we'll also talk a little bit about data population. This is an often ignored part of the development cycle. These days, I've heard rumors. I don't know if these rumors are true. I've heard rumors that there are individual developers who are not just 10x, we're talking 100x developers who are doing a million things. So they have to be comfortable with, obviously data population, running, large scale ETL pipelines, all of that, right? So having one pane of glass to do many of these things is extremely helpful. And this is where, data population can seem like it's a simple thing, but it actually drives the development cycle. And then another key detail that I think is super important to keep in mind is configuring skills, specialized agents, et cetera. So we'll look at that. I don't think any of you will be surprised to know that Neha built that app that she just demonstrated with Gemini CLI. We will focus specifically on the integration with Spanner, but Neha brought to bear her deep database and Spanner expertise across, right, the breadth and depth that Spanner brings. So, and this is an important detail for us to keep in mind. We're expected to wear all these different hats and scale in ways that are a little bit jarring, but I think if we lean into it, we can do pretty amazing things. And so this notion of configuring skills so that you're priming the LLM is super important. And then lastly, we'll implement a small feature in the overall travel planner app that Neha demoed, just so we can see what that flow looks like. All right, so this is Anti-Gravity. It's a Visual Studio Code-based IDE that brings a number of cutting edge models. I'm using Gemini Flash in the interest of low latency, and you can do this with Quad Code and a few other models as well. So I'm going to start with a simple task, right? So if I wanted to just look at all the tables in my database, right? So this is where I would have to pull up most likely the GCP console, or remember the G-Cloud command that I want to run. So here I'm running this with a natural language query. Show me the tables in this particular database. This may seem like a simple thing, but the key detail I want to point out and I want to contrast with MCP later on is the fact that this LLM is using G-Cloud, which is one of many tools that this LLM can use. And having MCP integration later on, one, it's lower friction. It is typically lower latency because once the LLM discovers the tools that are available through an MCP server, it rapidly responds as opposed to it having to kind of figure out how to use the tool every time and do things in that way. The other thing I want to emphasize real quick is this notion of authorization. When you give unfettered access to a tool like G-Cloud here, I mean, it's great. It's a double-edged sword, but at the same time, you're not able to carefully reason about what kind of access you want to give the LLM. Whereas with MCP, you can certainly do that. So please keep that in mind. So with that said, let's actually switch over to Gemini CLI. Hopefully you can still see my screen. This should be showing you Gemini CLI. We'll spend some time here. Great, thank you. So the first thing we'll do is I'll spend a little bit of time mentioning that I've configured the MCP server here that Jagan was referring to earlier. This is a fully managed MCP server from GCP, and this is for Spanner, but you can configure similar MCP servers for BigQuery and various other services, allowing you to use natural language. We don't have time to demonstrate this here, but I want to emphasize that you can actually lock down these tools with finer grained authorization. So please take that away from this session as one of the reasons to prefer this, if at all possible. Now, let's run the same query that I ran earlier in Anti-Gravity. And once again, this is just a way to show you this contrast, right? So I'm going to ask Gemini CLI to list the tables in this database, and it responds pretty quickly. And it actually also tells me, hey, I actually used this MCP server. I didn't have to run G-Cloud, right? And so as I'm working through this demo, you'll see me using, you'll see Gemini CLI using tools in this MCP server as opposed to G-Cloud. So that's super helpful. Now, in order to help me go through the rest of the demo or frame the rest of the demo, let me step back and look at what we're trying to do. So we have this travel planner app. I basically copied what Neha did and said, hey, Gemini CLI, build a shell for me, kind of that looks the same as it was what Neha built. And it's essentially got one of these cards filled in right now. And what we're going to do is implement another card, because that's really all we have time for. So this card involves implementing semantic search that retrieves the best beaches in San Francisco. And just to emphasize, since Neha went into great detail on all the multi-model capabilities of Spanner, I won't do that here. I'm trying to emphasize the vibe coding flow and just give you some tips and pointers. So please keep that in mind. So anyway, when you are looking to build a feature like this, right, as a developer, one of the things you want to do is step back and go, okay, which database tables am I going to touch? And what types of queries do I want to run, right? Now, with the benefit of LLMs, what you can do is obviously you can run these or run this natural language query that I have here, but then you can also say, show me the entries in the attractions table, right? And this is a natural language query. I mean, I could have easily just done a select star on this table, but just for demonstration purposes, you can do this. And so it returned these results. And you can see here, there's one entry that says beach, which should be returned, right, when this feature is fully built out. But from a data population standpoint, I'd like to be able to insert more records. So as I'm developing, I can see, you know, kind of rapid iteration, quick feedback. So this is a great place to use LLMs to insert data. And what I'm going to do is quickly show you a data population script that the LLM built. And this is just a Python script. And here's the, I apologize for jumping around here. Here's the prompt that I gave it. And I also indicated to it, hey, when you build a script, make sure it's idempotent so that I can keep running the script over and over again. And what it did was it looked at the schema and then came up with the data population in such a way that it also accounted for the embeddings tables, right? All of that stuff. It understood the connections and built out the data population. And you can really dial this in if you create a separate skill, as we've done for the query skill, which I'll talk about in a little bit. So I just wanted to plant a flag there and mention that you can fine tune this data population using these LLMs. So now I've got data in here that's already populated. And then the next step is to get the LLM to make sure that it crafts the right queries. And this is where it is super important to make sure you've primed the LLM, you've given it the right context. And to do this, different vibe coding tools, whether it's Gemini CLI, whether it's anti-gravity, Claude Code, right? They have this notion of skills. Claude Code calls it agents, where you can put in context relevant information that may not have been available when the LLM was trained, or it's not easily Googleable. So I strongly recommend, you know, being kind of educated about what you're looking to do, and make sure you prime the LLM with sufficient context, or relevant context is more important, I should say. And this is just an example where I've created a specific query skill. But to, you know, talk about like other options here, you could have created separate skills for graph, for full text search, for hybrid, right? And really primed it in such a way that you go kind of really deep on what that skill can do. And I haven't done that here because we don't have time, but I just wanted to mention that that should be a takeaway as well. And make sure that you spend a lot of time thinking about how you create these skills. Once you've kind of written up what you'd like to be in a skill, what you can do is go into Gemini CLI here, /skills, and I've already pre-configured it. Essentially, I took all of the text that I have here and plopped it into this screen, and that allowed me to essentially issue the next prompt, which I'll show you real quick. So this is where we're going to build out this feature, which basically involves telling the LLM, hey, I want to build out the semantic search card, and I'd like you to use the spanner query expert skill. And so this is a skill we just configured. And I've also given it some additional directions so that it doesn't, you know, choose a deprecated library. And so let's actually plop this into Gemini CLI, and it's going to go its merry way and build this out. Since we don't have time, once again, what I've done is I've already kind of, I have a fully baked version in the oven that what I'll do is I'll populate, using the data population script, I'll populate some additional beaches so you can see the results. The data population script is running, it's putting data in Spanner, And I'm going to start up the second application on a different port 8001. Let's bring that guy up. And when I go to the semantic search results, you can see that it built out the page, and we can see the relevant beaches here. And quick note here, I mean, you may be wondering, why isn't Baker Beach #1, right? So the nuance here is I actually haven't included the embeddings for ratings in the, the values for ratings in the embeddings. And this is actually an opportunity to kind of reemphasize the fact that when you create these skills, it's important to make sure that you put some thought into them and make sure that you fully bake into those skills all the capabilities that Spanner has. All right, so just to summarize, we started with something as simple as using natural language queries to look at your data, listing tables, tool use options, whether it's using gcloud or using MCP servers when they're available. And then I think the main thing to take away here, I would say, is to put a lot of thought into how you're crafting these skills so that when you're building something on top of Spanner, which has a lot of capability, that you're able to fully exploit Spanner's capabilities. So with that, I will hand it over to Jagan. Thank you.
Great. I'm going to go back to the slide deck just to sort of recap what we saw. So Neha really covered the skills. Neha, do you want to walk through this and how it maps to the multimodal capabilities that you showed?
Yeah, absolutely. So I think I did cover this already, but yeah, I can quickly go over it one more time. So here, basically what we said was that all the models within Spanner are interoperable. So I think there was a question on chat as well, that are these all in Spanner? Yes, they are. So, you can start off like, this is one query with the Spanner where we're trying to find out family fun attractions near the beach and the restaurants that are close to them. So you can see there's a graph syntax there. There's obviously OLTP query there. The semantic search, and then there is the OLAP count function that we're doing. So everything within that particular consolidated query in Spanner.
Thank you, Neha. So we really think this is really where the power of multimodal comes in Spanner, and bringing all this together into a single database. So we are excited to have you explore this and see what you can do with this. Couple of things to talk about is that we have this capability as part of our overall set of database services. We have various capabilities, including our Postgres-enabled Postgres primary databases, such as AlloDB. We have Cloud SQL that provides MySQL as well as SQL Server and variants as well. And then BigQuery for analytics that you already know, and Bigtable for low latency serving platforms. So we have a full set. They're part of Oracle, they're part of Google Cloud, and they are available to you for trials for you to try out. And we have partner offerings as well that allow you to complement them. Last plug, I want to sort of just make, some of you are part of the startup ecosystems. There's actually a Google for Startups Cloud program that allows you to give you credits to get started. There's financial sort of incentives. There's business resources, technical resources, as well as marketing resources. So in case this is of interest, there's a QR code that links to the Google for Startups page. And with that, I think that's the last slide. We have a couple of code labs here. I've dropped in my email. So if you have any questions about this or anything that you'd like to share in terms of feedback, there was no sort of form that we had. So I just figured that it's best to reach out, as Xooglers would love hearing from you. My email address is there, jathrey@google.com. Looking forward to your feedback. Nick, is there anything you want to say before we turn it over to Chris for Q&A?
No, thank you, team. Thank you all for joining. This is fantastic. This is one of our first Google Cloud engagements with our Xoogler community, so it's fantastic to connect with you all. I'm going to drop in a few links because there was a few questions and some interest in data and AI roadmaps. I've just dropped in a link to one of the latest ones. In May, coming up relatively soon, we'll have another round of data analytics, databases, AI, even BI roadmaps. So we'll ensure that we connect with Chris and get all that great information out to the community. And we look forward to more feedback from this community. It's fantastic to connect with everyone.
Awesome. Thank you, Nick, and thank you to all our presenters. Let's do some open Q&A for the next 10 minutes. And then the first question was, can we get the slides? And I believe it's going to be a yes, right, Nick?
Yeah, slides are okay. And this presentation, all the demos are also going to be recorded. So for those that didn't make it or want to watch it again or share with colleagues, those will be available. So we'll get those onto the community as soon as they're ready.
Here we go. Elena, please go ahead.
Yeah, I have two questions. So Neha shared the agent that she built. How long did it take to set that up, the agent?
Yeah, that's a good question. So I didn't really use an agent. It was more on the SQL capabilities that I was trying to show you. So I think what Karthi did was he built an agent. So for me, it was more like on the traditional side, and I used Gemini CLI to populate the tables and the SQL queries as well. So that was like a couple hours. So.
A couple hours, yeah, I was just curious. And then the second question is the use cases. I'd be curious to see what are the use cases that people are using, that companies are using from an enterprise perspective on with this product. If you can share a little bit more about, you mentioned a travel agency, right? But what are some of the other applications that you're seeing that are successful in this, using the product, and how? Mm-hmm.
I'll share with you 3 examples. This is Jagan, Athreya product manager. So we have sort of 3 use cases, and this is really pretty widespread. So I'll give you an example of a financial services company that has multiple diversified products. And so what they would like to do is, based on the user's interaction, when they ask for like questions about, hey, I'm trying to improve my savings rate, etc., they can steer them towards other products. It could be from their brokerage side, could be like fixed income assets or things like that. So it allows them to do a lot of cross-selling. Or for example, if they are, if they offer sort of banks and they've been long-standing customers and really good credit scores, they might suggest loan products, etc., as well for their home. So that's one example. Another example could be things like, if you are in the customer service and you wanted to personalize, troubleshooting of your, like typically if you're a telco and you bring in a device and say, hey, this is not working, you can use things like broken phones, broken images, and say it'll check your warranty and say, hey, this is covered under warranty, and essentially do entire customer service experience without having to get on the phone or being on sort of permanent, chat, waiting for a response, etc. Because now the agent is going to look up your device, look at your entitlement for repair, and do all that sort of in real time as well. That's another. And this applies not just to sort of retail, experiences, but also manufacturing. Like if you are in an industrial manufacturing type scenarios and you want to troubleshoot like a complex part, you have some complex machine that you maintain, and the gear number 234 has stopped working, and is it a wear and tear issue? Is it a service recall? All that can be identified using sort of prior history, prior sort of customer reports, etc. So it's very, very broad spread as a capability. Go ahead, Duke.
Yeah, great presentation, guys. Thank you so much. Are there any commercial licensing issues or licensing costs associated with commercial deployments using this?
These are cloud services. There are trial accounts that allow you to sort of try out and build these capabilities. And I think if you get credits from the startup program that allows you to keep developing even after your free credits run out. But I think there is an expectation of, if you're going to build a production app and deploy it, there'll obviously be some level of commercial arrangements you'll have to come to pay for and use those services. And I think those are also negotiated depending on tier. So if you have obviously a higher degree of consumption, you can probably get a higher discount. And I'll also turn it over to Karthi for any additional comments.
Yeah, this is a great question, Duke. So to add on to what Jagan said, we also talked about and demoed tools that are truly open source. So a good example is the Google ADK, which is something you can use, license free, and you can choose to deploy it anywhere if you wanted to. So that's something to keep in mind. And the LLM tools that we showed you, I mean, anti-gravity right now, I believe, is still is free, so to speak. I mean, at least it has a free tier, and Gemini CLI, I believe, also has a free tier. So there's a lot to explore there. Yeah, I mean, the cloud services, just like any other vendor, when you're using things like Spanner, we do offer free tiers, but for commercial use, you will have to, pay for it. I think Nick probably has more to add. Yeah.
Okay.
Yeah, that's right. Oh,
Sorry,
go ahead, Duke, with your follow-on question, and I can add a little bit more in after.
just a quick follow on. I know Spanner has access to lots of databases, right? So is all of the data available for us when we build a product?
So just if I understand your question correctly, Duke, what you're saying is so what we showed, what Karthi and Neha showed today was sort of taking sample data and building a sample app. If you're looking to build your own app, there are both commercial and open source data sets available, so which we essentially CSVs that you can import into your Spanner if you want to start using it. But that's typically how I've seen other folks try it out and start using it. But ultimately, if you're going to build a commercial app, obviously you'll have to build your own data set, whether it's like things like what Karthi said, which is interesting places or locations or restaurants or machine parts or movies or games, etc. So you'll have to build those out yourself.
Just to add to that, so when you use Spanner Console, when you're trying it out, we do have like a couple default data sets, which are very small, just to kind of start you off, but they're sort of like very generic data sets, just if you want to play around with those.
Okay, thank you.
Yeah, Duke, and just to close out, like I think many of you are familiar with, this is Google level scale and efficiency, and so you do get that added advantage of a fully integrated set of capabilities from your data foundation up to your AI layer, which adds efficiency gains in the market compared to alternatives. I think Karthi mentioned a great point around open source. We want to work with all of the open source technologies and ensure that there's openness and efficiency, and that you can leverage some of those open source capabilities. And then yes, 100% to take advantage of our cloud credit programs, our programs like the startup program to begin to create your applications and run those and gain advantage of the programs of scale. But there isn't any sort of additional pricing, licensing, packaging outside of how we license our cloud products for these capabilities.
Any final questions? We're about 2 minutes to the end of the hour. Jagan, I think you got probably emails in your inbox since you provided your email versus live questions here. So thank you for providing that.
This is a close, trusted community, so I'm really looking forward to the conversation with the team at the Xoogler. So,
any final words, Google team, or?
Well, I'll just say try Spanner and see the magic for yourself, I guess.
Awesome. So thank you all for giving up your time preparing for this presentation, giving the presentation, opening this up to Xooglers, and thank you all for joining Xooglers, watching it live or watching this on record. And send me an email or send Jagan an email if you want to hear more from the Google team. We'll love to be able to provide more benefits to the Xoogler alumni community. So thank you for being a part of it. And send me an email if you want to speak or host future events. Chris@xoogler.co. Thanks for joining everyone today.
Thanks all, and thank you, Chris. Bye.
thanks all, and thank you, Chris, again.